here. With this topic of the video for you, we're going to go over maybe pressure points here, and we're going to get it under control. So let's take and what's called the inherent domain essentially means all the value you can put into x. Okay, so the function is defined. Okay, so the range of numbers that you put into x, which is the independent variable, okay, which will yield a dependent variable y value that exists. So it's not defined, you're not dividing by zero. And the range, okay, is once you input all those values, all the domain values into x, which values are you going to get out of the function? Okay, so there's two ways to do this. So the domain, okay, we just look at the function we have, and we can solve for it either mathematically or just, we can just look at it and see whether or not values are okay to put in. Okay, and the range, okay, is basically, if we input for some function, in a second, the domain input for some function is equal to the range, okay? So that means, let's start. So the first question is fairly simple, so we have what's called a polynomial here, okay? And for any polynomial, all right, the domain is going to be all real numbers, okay? So for a polynomial number, we're going to put into x, the domain function is defined. Okay, so we simply put, okay, the domain is equal to, we have all real numbers, so we're going to write it as from infinity to infinity. Okay, so with this definition as well, we're going to use circular brackets always for infinities. Okay, so circular brackets means do not include, square brackets means include this number, but for infinity, to track that, just use these circular brackets. Okay, now for range, like I said before, we're going to use the inverse of the function. So what does that mean? Well, all these is we're going to flip the y and x values and we're going to solve for y. Okay, so if we write it as, so this is y equals 2x plus 1, so let's write it as x equals 2y plus 1. Okay, and solving for y, we should get, here I'm going to draw the arrow, we should have y equals x minus 1 over 2. Okay. So this is the inverse of the function. And as we can see here, there's no value that we can put to x that makes this function undefined. Okay, so as a result of that, the domain of this inverse function is infinity, or all real numbers negative infinity to infinity, which means that the range is also negative infinity to infinity. Okay, so that's simple enough. I'll just give these the red box for you. Now let's go to the next one. So now to explain, let's do it a little quicker. So once again, we have a polynomial, and we know with a polynomial, the domain is always negative infinity. However, if we have a polynomial to the second, the third, the fourth power, we always need to check what our range is. Okay, so our range is automatically this. All right, that's just the domain. So how do we do it? Same way. We take the inverse of the function. So we're going to say that x is equal to y squared, okay, and y is equal to square root of x. All right. So we simplify that. Now we have a condition here for the range. What we're solving the domain and the inverse is that when we put the value for square root, it always needs to be greater or equal to 0. Okay. So let's take inside the root over here, and we'll say that x must always be greater than or equal to 0. Okay. And now the definition is we're done. Now we have the domain and the inverse, okay, which is going to be, and it's including 0, okay, because it's greater than or equal to the root, and that's going to go to infinity, okay. So our range will be, for this function, 0, infinity, alright. Fairly simple. Now let's do one little trick here, okay. So let's take a look at this one down here, alright, we have g of x is equal to 1, x plus 6, okay. And as we've discussed before, okay, if we take the inverse of the function and we find the domain of that function, that is going to be our range, or equal to our range, okay? So, well, we have to look at the kind of function that we have, and we have to determine where